Hi guys, I'm Santosh Sharma. Welcome to my channel techguruforyou.com, and today we will discuss persistence, and there is a little bit nasty notepad, so I just removed it. Okay, so I will explain you about persistence today, and we will see why persistence came into the picture. Today, I will also explain you the HTTP history. We will discuss the difference between HTTP 1.0, 1.2, and then we will discuss connection, sessions, cookies, and persistence. So I will make this video with the combination of all those things together to understand the need of persistence. Okay, so let's begin. To understand why this thing came into the picture, persistence, not tech guru, persistence, uh, we have to go back and understand our HTTP. So if we talk about HTTP 1.0, which came in 1996, it's HTTP is a stateless protocol and it's a request and response protocol. Request and response. What does it mean? Client will request something and server will give the response. That's the request and response protocol. So every request is individual. Okay, suppose this is one request and second time there is another request. So this request is not aware of its previous request. Okay, so every request is independent. That's why it is called a stateless protocol. So it is not aware of the state of previous request. Okay, so when we talk about 1.0, I don't know how to remove. Let me remove, erase, medium, I think. Okay, what I will do, I will take slide by slide, I will take another slide. So 1.0, when 1.0 was there, and there was a one concept like one connection is equal to only one request plus response, RES. Okay, so what does it mean? Like if there is a one page, maybe suppose my website, you have opened my website, techguru.com. Okay. To open a website, first three-way handshake will happen with the server and connection will initiate it. Three-way handshake, connection established, and then client will send get request. Okay. When page is open, and now in this page, suppose there is one image here, one image here, one image here. Okay. So you are in my website's homepage and you want to now download this image. To download this image, another connection will get initiated, three-way handshake. And once it is established, you can send a request. Not you, I mean you, the client will send a request to download this image. And on the same page, if client has to make another request, another three-way handshake will go. Okay, so three-way handshake will happen. I mean, SYN will go, then acknowledgement. So then he can download. So everything was like that way. But that's what it was initially invented like this way. Not invented, I would say made in such a way. And over the period of time, like there was need felt where they think, okay, now our websites are becoming more complex, you can say, not that much, but yeah, they were adding more stuffs in the uh, page. And every time, if suppose there are multiple things in a one page and every time there is a one connection need to be initiated for one request and response, this server's performance will really go down, right? Because server has to create a connection, has to respond for SYN. Okay, and it's not only one user, there will be a lot of users accessing that application. Okay, so that was really a great issue. Okay, now I will copy this image and I will use another page. So after 1 year, 1997, HTTP 1.1 came into the picture. Okay, so 1.1, what happened in the 1.1? It was a vast change in internet history. Why that so? Now, one connection can support n number of request plus response. I'm treating one request response as a one because one request will go and its response will come. For that, one connection was initiated earlier. So for every request and response, another connection was initiated. But now, suppose you are in my website in a home page and I have added so many documents for you to download. Okay, F5 document, Palo Alto document, and you have initiated a three-way handshake to the server. With the help of that three-way handshake, we have one connection, and now with that one connection, you can download these all images. Okay, so it has really improved the performance of the server, and also, now this server can serve more users. It has now more connections. You can say more connection, or you can say, okay, even if this server has 100 connection, and previously also it was having 100 connection, but previously only 100 documents can be served. Okay, but now with this 100 connection, a lot of requests can be fulfilled. But in actual, it's not 100, it will be more. Okay, depend upon the capacity of your server. So that was really drastic change. And then HTTP 2.0 came into the picture. So this concept remains same, but they have done a lot of changes. Like in HTTP 1.1, it was like the transfer of the data was in text format, and they changed from text to binary. Okay, so that was the change in these two. So this was the history of HTTP. Why I've explained this HTTP? Because now the thing will be easier for you to understand. Okay, so earlier, like the applications, I would say the websites were just only to download the things. That's it. Static websites were there. But over the period of time, technology has really done a lot of development, improvement, you can say, and new leader comes into the market. And now application are going to HTTP protocol. If we take an example of Flipkart, okay, or any application where you have to do the shopping application, so they are on browser and they have to track their user. Where is their user? When I say where is their user, means in which page their user is. Like suppose you are adding one glass of water or a bottle of mineral water, or you are adding a t-shirt in your cart. Okay, so your application should be aware like what you are adding. And if you want to delete, you think, okay, I have a t-shirt, I don't want to buy it, then you will cancel it. Application should know what you are doing. So that is called a state. Application should know the state. But HTTP is a request and response protocol, and it is a stateless protocol. How you can do state things, okay, where you have to capture the states. To cover this thing, another concept came into the picture, which is session. Okay, so what started happening now? For every request, if there is a request, uh, then what server will do? Server will assign a session, and there will be session ID that will be assigned. Okay, so session ID will be assigned to that. And in one session, there can be multiple connections. Okay, so what does it mean? Uh, to understand this, let's go to another slide. So suppose you are in a one page, and in one page you are doing multiple requests. Okay, that will go over one connection. that will definitely go over one connection because we have now HTTP 1.0 and 2.0. One connection can serve n number of requests. But consider that those requests should be on the same page. But if user visit to another page, suppose here is a button and it is taking him to the same website, but to another page, then another three-way handshake need to be initiated, means another connection need to be initiated. So how server, which is like application which is working on HTTP, will keep a record of previous connection, like what are the requests here and this connection. So session things comes into picture. Session keeps these all the connections. So one session is equal to n number of connections. Okay, so that's really interesting thing. Now server knows, okay, this session has a multiple connection and multiple connections has multiple requests and responses. So now your HTTP became stateful, like HTTP is still a stateless protocol, but with the help of sessions, we are now able to track the states. Okay, so that's becoming interesting now, but there is another issue. Your connection, suppose your connection is timeout. If it is idle, it will time out in a 15-second. Okay, and your session is still in the memory for 5 minutes. That's really illogical, right? If your connection is timeout in a 15-second, then what you will do with the session? It's like that you're going from one place to another place in a cab, and your driver is saying, "I will wait for you only for 15 seconds. If you are not there within 15 seconds, I will disappear." Okay, and then you have to manage another taxi. It depends upon you if you can manage or not. But in browser world, in HTTP world, users will get frustrated. They have to initiate another connection. This session will get terminated. Suppose this guy is doing a shopping. So if connection is gone, then there is no benefit of that session. Okay. You may think, okay, let's increase the connection time. So maybe let's make it also 5 minutes. And this is also 5 minutes. Now I can resolve the issue. Actually, you can resolve the issue, but suppose if these connections has to be in the connection table for 5 minutes, what will happen? They were only supposed to be for 15 minutes, 15 seconds, sorry. It's you can understand this with an example like you are going to McDonald's and everybody is staying there for 5 minutes. You can see how much big line will be there. Like users who are taking their order, they can come out within 1 minute, but they have been programmed to stay there extra 4 minutes. Okay, so you can understand wastage of resources, like wastage of the space. If there will be enough space, then it's okay. Okay, the same goes for the server. If you have a limited number of connections, suppose you are keeping 100 connections in a buffer, you also have a limited number of buffer. So either you need a lot of resources or you will end up by having degrade performance, not giving resources to another clients. Okay, so that's not feasible. Okay, maybe you will think that, okay, I will decrease down the session time to 15 seconds. That is also not possible. And why that's so? Because if if you think about yourself, are you going to order anything within 15 seconds? We just spend 5 minutes to watch the things. Okay, so that is also not feasible. Okay, so both the things were not feasible. Then another thing came into the picture. Very interesting. That's cookies comes into the picture. Still, we are not discussing about persistence. Okay, so now what is happening? Like you have visited one page and then you have visited another page. So there are multiple connections. Each connection might be having a number of, when I say n, don't think infinite. It can be one, two, three. Okay, so it's having n number of request responses, but behind one session, Okay, but suppose this session expire in 15 seconds, then what will happen? What will happen? Like we have session and we have another thing, cookie. So cookie, like if I talk about HTTP, cookie on HTTP, what will happen when user will send a request, get request, just take example of get request. Server will reply, but server will also ask him set cookie. Okay, so he will say set cookie. So what will happen? This guy, which is client, will insert cookie in its browser. Okay, and what is the benefit of that now? Now, for every new request, when this client will go to this server, he will also take his cookie with him. Cookie is just a token number, or you can say pass. If you have to go to your office, you have a pass. If you do not have a pass, then you would be treated as a newcomer or not known to the company, and you have to get a temporary card. Okay, and that expire in some time, but of course it works for 1 hour, but that's not a permanent thing. But cookie, when we talk about cookie, that's pass, permanent pass, and it is stored in users browser. So now you can think that connection is just for making like some requests and responses, but now we don't need to worry about 15-second thing. Okay, let it timed out. Okay, and let the new request come through another connection, but we have a cookie in place. Okay, so it will go with the cookie, and this server will identify, okay, this is the same client. I will add the thing in his cart. Okay, so that's the beauty of shopping website, where you have to add the things, you have to delete the things. So your all the activities should be tracked. That is tracked with the help of cookies. How you will come to know about the cookies? Nowadays, whenever you open any website, they are giving you option accept cookies. Okay, so that is a browser-based cookie, and that also improves the performance of when you are visiting the website. Okay, so that's also depend upon you. Like you have to say accept all, or you can also deny on that. But that is the concept of cookies. Okay, now we have a cookie in picture. Another thing is like suppose one server will get overburdened. Okay, so now what will happen if it is overburdened because it is getting a lot of requests? Then we have ADC, Active Directory Controller, or you can say load balancer, like F5 load balancer, Netscaler load balancer. We have also now AWS load balancer, Elastic load balancer. So they all are same, doing the same thing, just different vendor. So you have load balancer, and they can send requests to different servers. Okay, so now your load can be equally divided. Okay, but another issue comes into the picture. What issue? Like if you are taking the request and sending first time to this server and second time to this server, then all the benefit goes in vain. Like there is no use of all the technology. Why that so? Because user has authenticated with this server, and when the new request is coming to this server, he's not aware of that. Like he's not aware, like he will say, I have not authenticated you, and your session will time out, or you will get an error. It will not work actually because he is not aware of the authentication. Okay, so there should be a mechanism. If requests come to him, there should be another server. He can check, okay, this user is authenticated, or request should always go to this server. Okay, so to address this issue, persistence came into the picture. What happened now? Now you have load balancing technique. Okay, so you're load balancing into server 1 and server 2. But what is happening? If your request goes from server 1, we add persistence. We add also cookie. Cookie is also added. Okay, but then that is called cookie persistence. Okay, so cookie is added. Why cookie is added? I told you already, but we have also added a persistence because this server has authenticated this client. And next time when the request will come, only this server knows about this user. Okay, so cookie persistence is added. Persistence is called a stickiness. Okay, it's also taken a name from the Unix. They used to say it magic cookie. Oh, that is a cookie, but persistence is like which sticks and it will be bound to the server. Okay, so you have many persistence which you can apply, but that is not part of today's video. Today's videos was only to explain you about what happened, okay, and why we need a persistent. So to summarize, I think it's good to show you the presentation, and I will also share my another screen. Okay, so this I have already discussed. Like nowadays, there are also API. They need to authenticate, authorize over HTTP header. Okay, so to keep the story short, HTTP was stateless. Session made it stateful. Connection was timed out after 15 seconds, and session still in a memory. That was resolved by cookies. Okay, request going to the same server can overburden same server, which is handled by load balancer. Okay, load balancer now can send the request to another server, but that created another issue. Like if one user is authenticated from server one, server two is not aware of that, and his user can get the error. Okay, and if you are doing any transaction from your bank and your request should always go to the same server. If it is going to another server is not aware of that and your transaction will be interrupted. But this leads you to the situation that session cookies known by one server is not known by another. Persistence comes into the picture after that and which resolve the issue. Okay, so that was all about persistence, why it came into the picture. I hope you liked the video. Please like it if it's really helpful for you. If you don't like it, if it is not helpful for you, please dislike and please also give me a comment. Why don't you like? I would like to improve. And please also comment if you want another video on persistence, maybe type of persistence in F5. Okay, bye.